Hi. I can't start a talk without saying hi. It's pretty important. So this talk is called All Your Network Monitoring is Probably Wrong. And I think it's really important to start this talk with like the one thing I hope you take away from this, if you take away nothing else. And that is my favorite word, greetings. This is the best word in the English language. So greetings. I'm Joe. I like computers. I once had a blog called timetobleed.com. I no longer have much time to blog or bleed, but on Twitter you can find me at Joe Damato. I started a company called Package Cloud, and what Package Cloud does is it allows you to streamline the process of creating and managing repositories of Debian, RPM, RubyGem, and Python packages. We have a really dope SaaS service and an on-premise product, so you should definitely check us out because our software is really dope, and also because supporting bootstrap software is important for the health of the software industry. So anyway, you can follow along. The slides are on the blog at blog.packagecloud.io. So I want to start my talk by talking about a pretty interesting and important idea called cognitive load. Cognitive load refers to the total amount of mental effort being used in the working memory. And I think this is important for us to think about as practitioners in our field, because I think many of you would agree that there's just too much stuff, right? Like there's a lot of different databases, there's a lot of different apps, there's a lot of different libraries, there's a lot of different programming languages, there's lots of different ways of deploying stuff, and understanding how these pieces all fit together, it's pretty difficult, and it takes a huge amount of your time and energy and a huge amount of your brain power every day. And the interesting thing about human beings is that like when you're presented with something that's really hard to do, human beings develop like sets of coping strategies for getting through them. And I think that like one of the interesting coping strategies for dealing with just like too much stuff in computing is this coping strategy of copying and pasting config files. And you know, I don't blame anyone that does this. Like I've done this like whatever, infinity times, right? You find a blog post or you see something on Stack Overflow or whatever, and you have a bunch of config settings for like MySQL or like Java or like whatever, right? Like GC settings or whatever, and you copy and paste them and you throw them straight into production and you peel out. And you do that because like you just don't have like the time. Like there's just like too much stuff to do, and there's just like not enough time to do it all, and there's just too much software, right? Like not everyone can be an expert in every element of every piece of thing that you deploy. It's just not like feasible, it's not possible, it's not realistic. By the way, this idea is actually part of another talk I'm working on called Programmers Should Get Paid More and Work a Lot Less. Anyway, so cognitive load. Have you ever copied and pasted configuration or tuning settings that you didn't completely understand? Probably. And why, right? Like there's just too much damn code. Similarly, do you really understand every single graph you're generating in like your monitoring or your graphing situation? Like, I mean, if you just go on your computer and you like apt-get install like Munin or collectd or whatever, you're gonna get a whole bunch of graphs and stuff that are completely auto-generated. Can you really look me in the face as an adult and tell me that you understand every single thing that comes out by default? Probably not. And why is that? Because there's just too much damn code, right? There's just too many plugins, too many files in proc. There's just too much stuff to like really sit down and compute it all out. And if there's too much damn code to configure and tune, because you're copying and pasting stuff off of Stack Overflow, like me and everyone else, what makes you think you can actually monitor any of this stuff? And the spoiler is that you can't. It's just not possible. But the good news is that it probably doesn't matter that monitoring stuff is impossible, but we'll talk more about this later. So, okay, my claim that probably a lot of you would agree with is that the more complex the system is, the harder it is to monitor. But I don't necessarily think that complexity is bad, right? Like, I don't want anyone to walk away from this talk and think that like, oh yeah, this guy hates complexity. Like, no, I think complexity is a fact of life. Like, I think complexity is important. And I can give you a really good example. I don't know how many of you have ever played the cat game. It's a pretty cool game. And I think the cat game is like a great example of complexity because, you know, you want to download and play the cat game on your and phone because your and phone is a small portable electronic device you can use during taxi takeoff and landing. You want to message your buds because you're lonely. You also want in-app purchases because you need to buy more goldfish, you can buy more toys for your cats. You need to do this over a TLS encrypted connection because you have payments, right? This has to happen over a VPN because of China. And you're going to do this while flying because you're bored. And that's so, like I think that's okay, right? I think complexity, it doesn't mean complexity is bad. Like you just have, requirements of stuff that you need to live your life and to have fun, and I think that that's fine. But on a more serious note, two complicated things that I don't think are necessarily bad. Here's one example, the interstate highway system in the US, right? It's pretty complicated, it goes to lots of states, probably a ton of bureaucracy to deal with, manage, monitor, keep it up and running, and it's important, right? We need it. The Tokyo subway system, it's also complicated, but also important. So okay, you want to know one thing that's complicated? The Linux networking stack. And one of the reasons why it's really complicated is because there's all kind of features. Different NICs have different RX and TXQ sizes, limits, defaults, Ethernet bonding, IRQ modulation, N-tuple filtering, receive side scaling, receive packet scaling, receive flow steering, hardware accelerated receives flow steering, generic receive offloading, generic segmentation offloading, hardware accelerated VLAN IDs, hardware accelerated timestamping. You're probably using at least 2 different protocol stacks like IP and TCP and possibly UDP. And there's all kinds of tuning levers and knobs and everything from top to bottom. And there's all kind of bugs. And most of all, there's basically, literally, actually, really, no docs for anything. In fact, there's so little documentation about how any of this works that there's this really, really dope mailing list post that I found on the internet. Check this out. Someone sent this question, a pretty reasonable question. How can I find out the procnet info, e.g. softnet stat is for what purpose? Softnet stat's a really, really, really useful file in proc, but it's really, really cryptic. Oh, I forgot to hit next, yeah. It's really, really cryptic because it's just not documented at all. There's no names for any of the fields. It's just really hard to understand, right? And the response by the person subscribed to this really intense Linux mailing list, the response was, well, much of this is only well documented in the code. Here is an attempt at interpreting softnet stat. No guarantee that it is correct. Read the code. And in his message, he goes on to say okay, there's this thing called total that gets output in softnet stat, right? And it's the number of packets, whatever. There might be some double counting going on. I think the intention was that these were originally on separate receive paths. Who knows? If you're interested in the full networking situation, I wrote a blog post about it. It's literally 90 pages long. It's literally everything about the Linux networking stack you need to know, and it is literally available here at bit.ly/linux-networking. You should check it out if you need to know anything about networking. Anyway, I think that that's actually fine. I know I'm probably in the minority. I think it's actually fine that this is kind of bizarre, because as long as we're just honest about the operating constraints of the world, I think it's okay if things aren't perfect, as long as we can be honest about the state of the universe, right? So tarot cards. These are important because as I've learned from starting a company, you need to be able to see into the future very regularly. And it's kind of hard without these. So I'm going to see into the future right now, and I know that at least one person in this audience is currently thinking that random operating system has a better, faster, leaner, whatever networking stack than Linux, right? Plan 9 or whatever. And I just want to say that that's easily the most boring thing I've ever heard in my life. Anyway. So complex software, it's not necessarily inefficient, it's not necessarily bad, and I mean people expect a lot of complicated features, right? So there's a lot of code needed to support all this random stuff you want to do. See also the cat example. The bad news about complex software, right, is that you're supposed to monitor this complicated code, and then you're supposed to look at some graphs, and then you're supposed to know the answer. And this sounds pretty difficult, but it gets better. What if I told you a driver bug caused statistics to output incorrectly in procnet dev? Driver called the IGB driver. It's a pretty popular server driver. Probably many of you are using it right now. We're using it right now on our machines. The driver stats are updated via a timer every 2 seconds. Reading stats via ProcNet Dev produced stale statistics, but not if you read those statistics via ethtool, which I'm going to mention shortly, because ethtool uses a different code path. You can fix this by forcing a stat update whenever stats are read by modifying the driver and then redeploying the driver in production. I saw this in production, maybe you did, maybe you didn't, but what's interesting to think about, right, is that like this driver made it into production kernels with this bug in it and no one noticed, because maybe that means that no one actually cares about monitoring networking stuff, right? Like if anyone cared about it, like maybe it would have gotten caught before it made it into production on millions of servers in an Ubuntu kernel or whatever. Then again, it only matters if you're monitoring your network stats more often than every 2 seconds. And like maybe you aren't because you don't care, and that's probably fine and you're probably right, and I'll talk about that later. But if you do care, here's a picture of your future status. Your future status, if you care, is you need to notice a problem in your graph, start reading your stats, collecting code and plugin, whatever, realize the bug's not in your stats collecting thing, read your driver code, realize the bug is in the driver code path that ProcNet Dev hits, write a patch to fix it, rebuild the driver, and deploy it everywhere. Greetings. That's a lot of work just to monitor bytes sent and received, which brings me to a really, really important list that I'm going to share with you. List of things that don't exist. Descending order of probability that doesn't exist. The thing that definitely doesn't exist, free open source software, not real. The and singularity, and then calorie-free chocolate-covered bacon, and so on. So I know what you're going to say next. And what you're going to say is that, okay, like ProcNet Dev doesn't work, but Joe, my DevOps are the literal strongest, and they doesn't afraid of anything. To which I will say, to which you'll say, I'll just use the ETH tool. The ETH tool, for those of you who never use it, is a command line tool. It uses the ioctl system call to talk to network drivers. And not all drivers actually implement the interface. The ones which do generally do it differently. So what if I told you that when you use ETH tool to output driver stats, there's no standardized way of outputting those driver stats. Some drivers don't even implement the interface at all, and the ones which do use different field names. You probably wouldn't believe me, and that's fine because I'll reply by saying, oye, dale, comparemos. And I think like a good tip is like always have a slide in Spanish in your talk. The best part about this one though is like I'm waiting for someone to slide into my mentions like, yo, who's this guy Dale and what's up with this new Linux tool called Comparemos? Anyway, so we can take a look at the EC2 VIF driver, the IXGBE driver, and the IGB driver. The EC2 VIF driver, if you run ethtool-s on it, you get a single statistic, RX, GSO, checksum, fixup. What even is RX, GSO, checksum, fixup? I could tell you, but I would need like another hour. So in the words of my Italian-American family currently watching my talk from New Jersey, forget about it. So let's check my IXGBE driver on an AND real computer. ethtool outputs approximately 377 statistics. Here's a bunch of them. That's cool. Of those 377, this is going to be a real surprise, none of them are RX, GSO, checksum, fixup. All right, let's check the IGB driver on an real computer. ethtool outputs 112 statistics. Similarly, of those 112, none of those are RX, GSO, checksum, fixup. But the IGB driver and the IXGBE driver are both written by Intel for Intel NICs. So surely 2 Intel drivers will output similar statistics, right? Like it would just be really weird if the same company wrote 2 device drivers for similar NICs that outputted different statistics. So if we diff them, the diff between them is only 316 different statistics. And it gets better. Some of those statistics are measured in the driver, some of them are measured in hardware, which is fine, right? Like you're probably going to stand up and start screaming, monitor all the things, which I think is terrible advice, by the way, but you'll see why shortly. So okay, let's monitor all the things, right? One of the and things is this statistic, RX no DMA resources, which, like, if you're a device driver developer, you can probably guess what that means, right? So that's maybe not that weird. Non-EOP disks, all right? OS2 BMC RX by BMC. It's fine. Because probably what you're going to say to this is fine. I'll read the driver source. I'm really good at the kernels. All right, so let's check out the driver source. Pop open the driver source, try to figure out what the deal is with this RX no DMA resources, and this is what we find. This little loop thing that jumps in here and does a read on something at the very end. If you see at the end there, it says it's doing a read on something called IXGBE QPRDC. What? IXGBE QPRDC. You know what this reminds me of? This reminds me of like those towns in Wales or whatever, where the where the name is like as long as the stage or whatever. Anyway, so what that code's actually doing is it's doing a register read, right? So this driver, like many others, gets a bunch of its stats from the NIC itself. It does this by reading register values. So if it's reading some stuff off the hardware itself, right, like presumably we can look at the documentation, the NIC datasheet for this thing, and find out what QPRDC actually means, right? So all right, here we go. This is the datasheet for the Intel Ethernet controller X540. It is a mere 1,260 pages. Once you plow through your scroll wheel and make it down to page 689, you can find this right here. QPRDC apparently means Q packets received drop count, and helpfully Intel has specified the 3 cases in which packets can get dropped. My favorite is the last one, which is packet size is larger than RLPML, while RLPML_EN is set in the RxDCTL subscript N register, which definitely means something to someone. So success, right? Like, this is dope. All you have to do as an operations person is spend the rest of your life repeating this process. Just get the driver code, read it for every single statistic, figure out if the statistic is in software or hardware. If it's in software, read the driver and figure out what it means. If it's in hardware, read the data sheet and figure out what it means. Then graph it, then figure out what the graph means, and you're done. Greetings. What if I told you, though, that some of these stats aren't even documented in the data sheet? And in those cases, there's really nothing you can do except literally guess. You could email the device manufacturer. Good luck. I don't know if many of you will get this reference. This is from the video game Star Fox. Before you go on the mission and like the talking dog is telling you about invading a planet or whatever, like right before your mission begins, there's a little robot that comes on that just says, good luck. That's this. Anyway, that's fine. I know what you're going to say next. What you're going to say next is, no one cares, Joe. No one cares. No one cares about NIC level stats. It's too low level. ProcNet Dev works on my computer for send and receive. And it has high-level summaries of other stuff, like errors, drops, FIFO, frame, compressed, whatever. That's cool. But what do errors, drops, FIFO, frame, and compressed even mean? Well, if you look at the kernel source for ProcNet Dev, you can see this code that outputs the statistics for each of those fields that you'll see in ProcNet Dev. And if you notice, it might be kind of hard to see because it's kind of small, but some of the fields are actually outputted by combining other statistics fields, right? So there's like a few of them that are actually adding a bunch of other fields together and outputting them as a single number. So ProcNet Dev actually, all those fields actually come from the driver itself. Some of the fields that it's outputting in that nice file for you, some of them are from software and others are from the NIC, right? So, and some of the fields are sums of other fields. The good news is that this reduces your datasheet search space, right? Like, just search for the fields you care about, figure out what they mean, and then you can understand what like FIFO, dropped, compressed, and all that means in ProcNet Dev, right? Could be a problem though. What if the drivers don't actually agree with each other on what the individual statistics actually represent? In other words, what if driver stats RX missed errors means something different for every driver you ask? Greetings, friends. The meaning of driver stats is actually not standardized, and so you'll find a lot of cases where driver stats, the actual statistics don't agree between drivers. And BTW, the amazing thing is that stat meanings for a specific driver and device can change over time, meaning that like if you have a version of this device with like, version 1 of the driver versus version 2, maybe they've decided in version 2 to count a specific error a different way under a different category, which makes your life even better because now all you need to do, right, is just figure out which NICs are in prod for every single box you have, which firmware versions you're using on every single NIC, which versions of drivers are used for each NIC, read all the driver sources for the fields you care about, read the datasheet to figure out what the fields mean, and then build and collect D plugin or whatever to encapsulate this knowledge. But maybe you don't care. Like maybe you don't care about this either, right? This is still too low level. All you care about is protocol level stats. That's weird. Like you don't care. I mean, it's odd because like using ETH tool properly can eliminate protocol stack problems. Like you can actually tune stuff with ETH tool to get rid of receive errors, drops, and stuff like that. But whatever, right? Like you don't care about that. That's fine, right? So let's just read protocol stats from ProcNet SNMP, right? ProcNet SNMP. That's dope, right? There's an RFC 2013. The fields are standardized. This is great. It's higher level so I can figure out where the protocol layers are breaking down. And most of the stats are gathered in software. So that's much easier than reading a 1,200-page data sheet, right? Like I can just read a bunch of source code and figure it out, I guess. But what if I told you that there's lots of bugs in the way statistics are counted and output in the kernel? What if I told you that there's several cases where counters are incremented just in the wrong place, like we saw in that email that I showed you where there's double counting? There's several cases where there are double counting throughout the network stacks. There's several cases where the counters aren't incremented where you think they should be incremented. Here's an example from a comment in the UDP protocol code. It just says reporting eno buffs might not be good because it's not tunable per se, but otherwise we don't have a good statistic. We could add another new stat, but at least for now that seems like overkill. So who knows, right? Like who knows how these things are being accounted or if they're being accounted in a way that makes sense to you as a user or operator of the system. So if this is an important statistic for you, your monitoring might be wrong, and the alerts you set on that monitoring might also be wrong, which means that you can look at graphs when you have an incident and not know what's actually happening or what's going on. So what does this all mean? It means that monitoring something requires a very deep understanding of how that thing works at a fundamental level. Otherwise, your graphs, alerts, etc., might not actually be measuring what you think they're measuring. And this is why people can build entire businesses around monitoring networks or other stuff. And so I urge people to like resist the temptation of just trying to solve every problem with like a quick bash script that you shave out over the weekend. Because properly monitoring, setting alerts, and so on requires significant investment, not just like a simple script that you can just throw together. I don't think this is necessarily bad. I just think it's important to think about. I think it's important to recognize that monitoring is difficult and it requires time and effort. It means that, what else is this? Means that, nothing is free, but this doesn't mean that software is bad. I don't hate Linux or Linux kernel. Like I think the software is dope. I just think it's important to be realistic about how it works. So I hope no one jumps to that conclusion. I'm not recommending against using your computer. This is just reality. This is just the way it works, right? And this brings me to an aside. I think an important aside that probably as engineers or practitioners in this space we don't think about often enough. And that aside is this sort of connection between time, money, and business. I think engineers always think that they can solve everything by writing enough software. The problem with that is that sometimes spending your time doing that and writing software actually doesn't make any business sense whatsoever. And other times doing that is actively detrimental. How long would it take you to figure out if all your networking metrics are right, figure out what they all mean, set alerts that are sensible, right? Like remember, you need to probably read a lot of code, data sheets, different versions of different drivers. It's going to take a long time to figure out what this all means and put it all together. Hopefully the blog post that I wrote would give you a jump start, but like there's still a lot of work you have to do on your part. When I was thinking about this, I stumbled across this really cool calculator by the folks at Baremetrics. Baremetrics put together this calculator where you can try to sort of figure out how much will it cost the business to do a particular thing. So for anyone who's never like run a business before, you can check out this calculator. You can put in like the cost of an engineer salary per year. If you never run a business, make sure to add in 35% overhead minimum to salaries. If you have like deep tissue massages every day and like free lunch and all that, probably want to add in a lot more overhead than that. But anyway, this is why like the idea that monitor all the things doesn't make any business sense for most businesses below a certain revenue level. Right? Like if you're a small business, a small startup, you just got up and running, like monitoring all the things doesn't necessarily make that much sense unless like you already have previous experience at a deep level with the things you're monitoring. And this is kind of why it doesn't really matter if these stats are wrong, right? Like this is kind of why probably no one noticed when the IGB driver shipped with a bug in it that prevented stats from being up to date on 1-second intervals, because it just doesn't matter for that many people. And if the stats actually did matter, right, like your business or some business somewhere would invest the time and money to figure that out. So anyway, in conclusion, I don't think complexity is necessarily bad. Even simple software is buggy and hard to monitor correctly. It all just comes down to value and time, right? Your network monitoring is probably wrong, but probably not because of anything you're doing. It's just because it's wrong because the networking stack is complicated, it's hard to understand, and it's hard to internalize. But the good news is that it probably doesn't matter, because if it did, your company would invest the time and resources in figuring it out. I don't know if I have time for questions, so if I don't, and you want to ask me something about computers, I'll be around. So thanks for listening.